Okay.
Sorry.
Sorry, Angela. Here we go. The derivative of this is still 8 to the power times the natural log of 8. But what else do we need to multiply by?
-6.
-6. So you could, if you wanted, write it as -6 natural log of 8 times 8 to the 7 minus 6x. But that's about it.
Whoa.
Not necessarily complicated, just another rule to it.
Oh.
But we are just practicing our chain rule now. So let's look at this one.
Can we simplify first?
Nope, because it's not sine times cosine. It's sine of.
Cosine of tangent.
Yeah.
What
So
is-
this is a composition. Chain rule says you start on the outside. So the outside is sine. What's the derivative of sine? And the inside stays the same. So it's cosine, cosine, tangent x. Okay. Times derivative of the inside. So I'm working my way in. What's the derivative of cosine?
-sin.
Inside stays the same. This one's going to require.
Oh, we don't put the cosine up or the sine up there.
Right now I'm just writing. I'll simplify in a second. Okay. So we did the derivative of the outside one. The inside stayed the same. We're working our way in. Derivative of cosine is negative sine. The inside stays the same. But is my inside just an x yet?
No.
No, so we keep doing our chain rule. So times derivative of the inside. What's the derivative of tangent?
Secant squared.
Inside stays the same, so that's just x. Now, that's just a plain x, so I am done with my chain rule. At the very least here, I would ask that maybe you pull your negative out in front, but that's about all you can do. So we have cosine of cosine tangent x times sine of tangent x minus secant squared x.
I was thinking of the one where you do like then you do the derivative and then keep and then keep and then keep.
You're thinking product.
With the secant squared go negative, isn't that?
No, tangent's not a co.
Yeah. The co's have a negative derivative.
I mean by pulling the negative one out.
No, because this is all multiplied together. So this is like
okay.
a 1 times a -1 times a 1. Other questions?
I'm sorry, I'm probably gonna accidentally simplify it where I'm not supposed to.
We're going to practice this a lot.
Is that theta on the
Yeah, this is, I don't know why it printed funny. This is secant of 3 theta. So, starting on the outside, what's the derivative of e?
e to the power?
Still e to the power. That doesn't change. Times. Working our way in. What is the derivative of secant?
Secant tangent.
So inside stays the same. So it's secant 3 theta, tangent 3 theta. Times derivative of the inside. That inside now is my 3 theta. What's the derivative of 3 theta?
3.
So as far as simplifying, really the only thing I would ask is you at least pull the 3 out to the front.
This feels so silly.
Is it? I mean, it beats doing the definition.
No, I know, but like that, just that we're doing it.
Derivatives have a lot of applications. We'll start looking at a lot of them after this.
Oh yeah.
Does that mean word problems?
For sure.
Okay, let's look at this one.
Product rule.
Do you guys want to try it first?
No.
I double check.
What?
we have derivative of the first, so 2w minus 3 times the second, plus the first, times derivative of the second. Can I just go ahead and put my 5 out here?
Yeah.
Okay, times derivative of the inside. What's the derivative of the inside? 1. Anything times 1 is itself. So that's our answer.
Oh. Are you freaking out? Thought there was a trick.
Never mind, I didn't pull my five.
Oh.
Wait, let me just, I did mine in a different
Find
order than you
once
did.
with and without the chain rule. What is this?
What? Find twice minus once with and once without the chain rule.
That minus is just a dash, Carson.
Are you okay, Caitlin?
I don't know. He said,
I thought you said kitten, and I was like, what? You
all
okay?
right.
You're
I
right,
don't know,
kid.
so, this is the second part, cause I just did mine. And then I got yours. I don't know what.
We did plus the derivative of the second, so times the derivative of the second.
So happy.
You did first times the derivative. Should have been times.
Let me just rewrite this, cause,
You just had through an extra plus where it should have been times.
okay, let me just go. Derivative of the first,
You didn't pause, so that's all on video, but I was thinking you said kitten.
Derivative of the second
So
plus 4 times 1 plus x squared minus 3w plus 4, and then why is my stuff weird?
I just want to show you that the chain rule is working. I've given you two equivalent equations here. So here's the first one. If I asked you to do this derivative, we would have to do chain rule, right?
Oh yeah, we would.
So, exponent comes down, inside stays the same, subtract 1 from the power, times derivative of the inside is
Negative 1.
negative 1. And we would get there. If we didn't want to do the chain rule, so if we had done this last week, we would have to multiply it all out first. So we would have started with this one. That's what you get if you took that to the third power. So if I did that derivative, what do we get?
Negative
3x squared plus 6x.
3x, negative 3x squared.
Okay, so if we just start, derivative of 1 is 0, minus derivative of 3x, so negative 3,
Plus
plus
6x minus 3x squared.
These things are equivalent. If I took the first one and multiplied it out, that would be 1 minus 2x plus x squared, negative 3 plus 6x minus 3x squared. So I'm just showing you, you can do chain rule. Sometimes you have the option of multiplying it out first. It doesn't matter. You have to have an equivalent answer. I'm not saying it has to be written a certain way on these. Okay, I am going to stop here
Oh, okay.
for today. And I have a handout I want you to work